All right, so now we're going to use these rules that we've learned. We know now what the general rule for taking the derivative of a power function, and we also know how to take the derivative of a constant and a linear function. So that's what we're going to do in the next example, is just look at a variety of functions and apply these rules. All right, so first example, we have f of x equals 6. All right, this is just a constant function. So we can just say f prime of x, right, is equal to 0, right? Essentially, this is our k value. This is k. We just have a k, whatever the constant. The constant here is 6, all right? So this is just a constant function. So the derivative is 0, right? If we were to graph that function, it'd just be a horizontal line. The slope is 0. Next one, we have f of x is equal to x. Now this is a linear function, or you could think of it as a power function, all right? Because you can think of it as x to the first power, right? And we can find f prime of x by bringing down the power and then subtracting 1 from the power, right? So we end up with essentially x to the 0. Now what is x to the 0? X to the 0 is 1, right? So you could use the power rule, or you just recognize that this is just 1 times x, and so the slope of the line y equals x is just 1, right? So you could also just recognize that the slope is 1 of that function. Okay, so the derivative of x is 1. All right, let's look at x to the 5th. All right, so we're going to write f prime of x. Now, remember, this is a different function. This is not the same as the function we had before. So we need to label it as something separate. We need to label it as x prime of x, or f prime of x. So we're going to apply the power rule. So we're going to write the power is 5, and then we're going to subtract 1 from the exponent. Okay, so 5x to the 4th is the derivative of x to the 5th power. And we can do the same thing here. This time, because I have just y, I'm going to write dy dx. Sometimes I like to use Leibniz notation. So let's use Leibniz notation for the fun of it. I could write y prime if I want to, too. But so we'll remember the Leibniz notation. So dy dx is another way to write y prime, I suppose. So I'm going to bring down the power and then subtract 1 from the power. So 8x to the 7th is the derivative of x to the 8th. All right, now the next one isn't quite so straightforward. We got to recognize that this is a power function, right? If we use our properties of exponents, we know that the square root of x is x to the 1/2. All right, so now we have it written as a power function, right, where the power is 1/2. And the same rule applies. Even though the power is not an integer, we can still take the derivative of this function g of x in the same way. We bring down the power, which is 1/2, and then we subtract 1 from the power. Now, you could also think of it as subtracting 2 halves, right? So 1/2 minus 2 halves is going to be a negative 1/2. So we should write it as 1/2 x to the negative 1/2. Okay, so that's the derivative of the square root of x. So here's another one. It doesn't quite look like a power function as it's written now, so we have to rewrite it. This is where those properties of exponents come in handy. So you have to remember that 1 over x is x to the -1, and now it's a power function. So h prime of x, right? It's a different function, so label it as h prime of x. We're going to bring down the power, which is a -1, and then multiply by x to the -1 becomes -2. Okay. Now, if I want to simplify this, I could actually rewrite this as a -1 over x squared if I want to. All right. So in general, you don't have to still simplify. Now I could actually write this one as well as 1 over 2 square root of x, right, if I want to, but you don't have to simplify in this unless there's a reason to. Sometimes there's a reason to, but in this case, you could just, just show me that you know how to use the power rule. That's the important thing. Whoops. All right, we got a couple more here. And again, as they're written, they don't quite look like power functions. So we have the cube root of x squared. So remember that the cube root is a 1/3 power. So we have x squared to the 1/3 power. And then if I have a power to a power, I can multiply the powers. So this is x to the 2/3. All right, so now I have it written as a power function. So I can find the derivative, p prime of x, by bringing down the power, right? 2/3, and then x to the 2/3 minus 1, which is 2/3 minus 3/3. So I'll get a negative 1/3 when I subtract 1 from 2/3. Okay. So again, you can leave it like that, or if you want to, if you recognize that the negative exponent, you can flip that to the bottom, and the 1/3 is a cube root. This is the same as 2/3 cube root of x. But don't worry about simplifying. This is perfect. This is really what I want right here. All right, we got one more. Again, we have to rewrite it. This is the square root of x, so this is square root of t to the 1/2, and this is essentially t to the 1. And remember, when we have the ratio of two numbers with the same base, we can subtract the exponents, right? So t to the 1/2 minus 1 becomes t to the minus 1/2. Okay, now this, all I've done right now is just rewritten k of t so that it looks like a power function. I have not taken the derivative yet. So now that I have it rewritten as a power function, I can find k prime of t just by using the power rule. I'm going to bring down the exponent, so it's going to be negative 1/2 times t to the negative 1/2 minus 1. So negative 1/2 minus 2/2 is negative 3/2. Okay, so that's perfect form. All right, I want to say one more thing before I leave. There are you may find that there are online calculators that will do derivatives for you, but I don't want to see your answer in the form that they give them in. They usually give you a simplified answer, and it takes a lot of algebra sometimes to get to the answer that they will give you. And they also use techniques that you have not learned yet, and I don't want to see you using, chain rule or or quotient rule or product rule at this point in your academic career, and not in 108. Okay, you'll learn that stuff in 109, but I don't want to see any of that right now. I want you to use what we've learned, and if I see anybody using chain rule or product rule or quotient rule, no, I'm not going to give you credit for that. So be careful. Don't use them. You need to practice using the power rule and rewriting functions as power functions. So just be very careful about going to the internet as a resource, because it will not help you. All right, I will meet you in the next video for some more examples.